This is the pre-lab video for Lab 4 in Chemistry 231. And the title of this lab was How is Liquid Ethanol Produced and Purified? And we're going to see that we're going to be using a technique called distillation. And how the liquid ethanol is produced is we're starting with sucrose, which is a pretty complex molecule that looks like this. And recall we added yeast and pasture salt and things like that to the mixture with sucrose. And what happened was that meant that there was an enzyme in the yeast called invertase that is going to take apart the sucrose into its constituent sugars, glucose and fructose. And then an enzyme present in yeast called zymase will produce ethanol. Now, this is your reaction this week, and you know you started with a certain number of grams of sucrose, so you should be able to figure out what the theoretical yield of ethanol is. Notice you don't need to worry about this part of the reaction. You can just go from here to here. And notice for every 1 mole of sucrose, 4 moles of ethanol are produced. Now, distillation is just our third separation technique that we've learned. It's an example of a preparative separation technique. That means that we separate the materials and we are able to, we have material in our hands at the end of the separation. Recall that that was the case with our extraction. We ended up with our unknown and either our sucrose and aspirin at the end of the day, and we could weigh all of those. And thin layer chromatography, we were able to separate the components of an over-the-counter analgesic, but we didn't know how much of each one we have. Now, with distillation, that's a preparative technique, and at the end of the day, we will have, hopefully, very pure ethanol in hand. Now, a little bit of information about distillation. It's used for separation and purifying liquids, and as you saw in the MIT video, it takes advantage of a differential in boiling points. Now, we're not going to do a vacuum distillation in this lab. We're going to do a simple and a fractional distillation. As it said in the MIT video, simple works best if you have a more than 25-degree difference in boiling points, and fractional works best if there's less than a 25-degree difference in the boiling points of the two liquids you are trying to separate. You'll see that ethanol and water, which are the main components of the mixture you'll be separating, are pretty close to this line right here, and we're going to use both techniques to separate this mixture. Now, distillation has a lot of real-life applications, and that's another fun reason to learn about it. For example, it is how you get from crude oil to things like gasoline. But here are some applications where folks are separating out ethanol. The one shown here, Watauga County, which is up in northwest North Carolina, this is historically a very important part of North Carolina and in some cases southeast culture. That is the production of alcohol called moonshine from stills that are out in the woods hidden from view. And it's historically important, and it still is important if you know the right people. Another important application is the production of biofuels, so things like fuel ethanol, which can be produced from corn. And so this is just, you don't have to know all this, but this is just taking you through all the process. Once you get your sugars from the corn, you can then take that through the fermentation process, and then after distillation, notice that you get 190 proof ethanol, and I'm going to talk about what that means in a second. Then that goes to dehydration, and that is not a distillation process. We cannot get to what we call 200 proof or 100% ethanol through the distillation process. We have to use a different process to do that. Distillation will only give us at best 95% ethanol, which is referred to as 190 proof. So where does this proof terminology come from? Well, just real quickly, the idea of proof comes from the fact that British sailors back in the 1800s were paid in part in rum, so that was part of their rum ration. and they were very concerned that this might be this rum ration might be being diluted, and so that to be sure that it wasn't diluted with water and therefore didn't contain as much ethanol, what they would do is they would take the rum and they would soak gunpowder in it, and then they would check to see if the gunpowder would ignite. Now, if there was too much water in there, the gunpowder wouldn't ignite, but at a certain percentage of ethanol, which was 57.5% ethanol, what would happen is the gunpowder would ignite, and thus it was proved. And so in England, if you had, at that time, if you had what they called 100 proof ethanol, that meant you had a mixture of ethanol and water that was 57.5% ethanol. Now, in the U.S., 100 proof equals 50% ethanol, and the rest is water. Now, you'll notice here this is a image of a bottle of Everclear, and you notice, if I circle it in a better color, you notice here it says 95% alcohol by volume, or 190 proof. And that is not only the highest percentage of alcohol that you can buy at the liquor store, it is also the highest percentage of ethanol you can get in an ethanol water mixture using distillation. That's because when you have a mixture that is 95% ethanol and 5% water, it forms what is called an azeotrope. And an azeotrope is a mixture that has the same composition in the vapor phase as in the liquid phase, and therefore that makes it impossible to separate by distillation. So what it is basically it's a mixture of two different liquids with a constant boiling point. And that's very unusual, but it's also, I mean, it's not terribly unusual. There are several different ways that you can get an azeotropic mixture, but this is the most common, and it's the one most people are familiar with because it's the one that they can go and buy at the liquor store. However, you cannot buy this at the liquor store in North Carolina because it was banned in 2010, and now you can only buy, I think it's 150 proof. I'm not sure. I don't buy a lot of Everclear, I'll be honest. But it was banned because they did a study and found out that most Everclear was sold at liquor stores that were located adjacent to college campuses and basically was used to get people blind drunk. So that's why they banned it. Okay, really briefly, as they noted in the MIT video, the steps of distillation: first you have the vaporization that occurs, and that is enriched with the lower boiling component of the mixture, and then you have a condensation step that occurs that allows you to collect the liquid that has a higher concentration of that lower boiling component. Now, we'll see that simple distillation has only one of these vaporization condensation technique steps, and therefore isn't as efficient at separating a mixture as fractional distillation is because it has many of those steps. Here is your simple distillation setup. I just want to make a few notes of where this is different from the one that was described in the MIT video, and I know that she said in the video that this is the most complicated setup you'll do, and it is a little complicated, and it's going to be complicated the first time, but don't worry, you're working in groups, and also we're there to help you, and you'll be able to figure it out. So a couple of places that are going to be different. Notice here that we're just going to use one clamp to the ring stand, and that's going to be at the neck of the distillation flask, and it's going to support the entire apparatus. So we won't have a second clamp right here on the vacuum adapter. So I'll explain more about why that is, but we will not have that second clamp. The other thing that's different is that we're going to have this resting on a lab jack rather than an iron ring, which is that blue thing that some of you were using in your lab last week to support the beaker that was holding the test tube with your outlet from your fermentation in it. Also, in the distillation flask, rather than having a magnetic stir bar, we're going to use something called boiling chips, and boiling chips do the same thing as the boiling stick you had last week in your recrystallization, and they just prevent the mixture from bumping. Other than that, the rest of the setup is pretty much the same. Notice something that's really important here is the water goes in the bottom of the condenser, so that's coming from the water outlet, and then the water comes out of the top of the condenser, and that's what's going to the sink. So that's like I said, that's exactly the same. The only other big change besides the lack of a clamp here is that rather than collecting in a little round bottom flask, we're going to collect in a graduated cylinder, and that way it's really easy to see when you've collected 50 milliliters of solution. Hopefully when you come in this week, you'll see something like this in your hood, where now you have this mixture of ethanol, water, and yeast. And we're going to take this liquid and distill it, but before we do that, we need to filter out all the dead yeast. Now, the dead yeast is really sticky and nasty and will clog up your filter paper, so we're going to do a vacuum filtration, but we're going to add in something called a filter aid, and it's called Sea-Lite. And that Sea-Lite is going to help. It's not going to work 100%, but it's going to help keep the filter paper from getting clogged up. So here's what we're going to be doing over the next couple of weeks. In week 1, that being this week, we're going to add about 10 grams of Sea-Lite to your fermentation, and you'll swirl it around to get it mixed up, and then you'll vacuum filter it. And that is something that you're working in groups. One of you should go ahead and start that as soon as you get started in the lab, because it does take a while to get that filtered. Then while that's filtering, you can be setting up your simple distillation. And once we get the distillation going, you will collect 50 milliliters of distillate. And then what we're going to do is we're going to take 10 milliliters, and notice I've got 10.00. That's because you're going to be using a volumetric pipette to be able to measure out your 10 milliliters of ethanol. Then once you do that, what we're going to do is we will weigh it, and you will be able to get the density in grams per milliliter. And then you'll be able to use this table that's in your lab handout in order to determine the amount of ethanol by weight and by volume. And notice, if you have a number for your density that isn't exactly equal to the densities that are listed on the chart, you just go by whichever density your measured density is closest to. Then you're going to put that 10 milliliters of solution, back together. So for week 2, you will have that 50 milliliter sample that you had from your simple distillation, and what we'll do is we'll then take that through a fractional distillation, and then we'll see if we increase the amount of ethanol that we get, and if we can get up to between 95 and 96%, which is the purest possible ethanol that you can get by distillation. All right, when you're distilling, don't forget that for every, I think it's 2 milliliters that you distill, you want to record the temperature, because we're going to be graphing that. Just a couple of reminders about the vacuum filtration. This time we are keeping the filtrate, and that is this stuff that's down in here. That's what we want to be keeping. And it's always a good idea to disconnect the hose before you turn off the vacuum, because by the hose, I mean that right there. The reason is because if you don't disconnect the hose, what can happen sometimes is the vacuum can suck back things out of the line into your stuff here, and since you're keeping the filtrate this time, you don't want to contaminate that. And as I mentioned, Sea-Lite is a filter aid that helps prevent clogging of the filter paper. Just a couple of notes about heating mantles. One of the things to note here is that they're used to heat reactions or distillations, and that we can do it without flames, because things are very flammable in the organic lab. One of the things you remember is here are 2 of the heating mantles, and this is called a variac, that's what I've circled right there, and that is in between. So the variac, this is plugged into an outlet, and your heating mantle, which yours is going to look like this, is plugged into the variac. Don't plug colors. Don't plug the heating mantle directly into an outlet, because then you will be putting through, these are basically like a heating pad, right? You plug it in and then it gets warm, okay? And if you think about it, the little key pad on your heating pad that has, hot, medium, hot, or low, high or low, is kind of what the variac is. So if you plug the heating mantle directly into the outlet, it will get super hot because it's direct house current, and it will probably start to smoke, and it will probably catch on fire. So we'd like to avoid all of these things. So do not plug the heating mantle directly into the outlet. You want to take your heating mantle plug and plug that into the heating mantle, and then this cord right here is going to be the one that goes to the outlet. Lastly, as they said in the video, if your heating mantle is not a perfect fit for your flask, you can fill it with some sand to help transfer heat. And that's about it for this week. I just wanted to show you a picture of my assistant who helped me make this video. I think he did a pretty good job.